All right, y'all, so 7-1. And it's a fairly short one. We're just looking at symmetry. Y'all familiar with symmetry, right? Like our bodies are symmetric. If we cut it down the middle, one side would be pretty much the other side.
Yeah.
So on graphs, we're going to look at 3 types of symmetry, okay? So the first one would be symmetric to the y-axis. So to be symmetric to the y-axis, I would fold my graph along the y-axis and fold it over. If it lands on itself, symmetric to the y-axis. So if folding the graph along the y-axis, and the graph lands on itself, then it is symmetric to the y-axis. Okay, so let's look at symmetric to the y-axis. Those parabolas y'all been graphing. So if I had me a parabola, but if I took this graph and folded it over that y-axis, this left side would land right on top of that right side, okay? So that's definitely symmetric to the y-axis. Another thing, if it's symmetric to the y-axis, it is what we call an even function. Okay. So y'all, I got another axis I can be symmetric to, and that's the x-axis. That's pretty much the same thing, right? If I can fold my graph along the x-axis and fold that top over, and it lands on itself, then it's symmetric to the x. So all this except put x's on where the y's are, okay? So we have folding the graph along the x-axis. And the graph lands on itself. Then symmetric to the x. Okay, so let me see. To be symmetric to the x-axis, well, let's see, I could have a something that looks like that. So notice on this one, I'll just take that top, fold it right over the x, and my top would definitely hit that bottom graph, okay? Are y'all hearing me on mine?
Yeah.
Yes.
All right, y'all, so here's the thing now. I've looked at symmetry to the y-axis and the x-axis. The third symmetry is to the origin. So symmetric to the origin. And you know, the origin of the graph is that center, 0, 0 area in there, okay? So to be symmetric to the origin, if turning my graph 180 degrees, so if turning the graph 180 degrees, so basically you're taking the paper, turning it upside down, okay? Results in the same graph I'm going to take my graph, I'm going to turn it upside down. If I get the same graph, symmetric to the origin.
So would that example above it be symmetric to the origin?
This one?
Yes.
Oh no, this one was symmetric to the x-axis. Because see, if you turn this one 180 degrees, this stuff would all be on that side. So let's see, turn the graph, results from the same graph, then symmetric to the origin. So an example of being symmetric to my origin. And y'all remember that origin is that little center on this, okay? So to be symmetric to the origin, you might have something that comes up, curves over, and goes back up. I'm not as nice drawing them as the math lab. But notice, this is going uphill left to right. If I turn this 180 degrees, this end would be down here, but my graph would still be going uphill left to right. So it would still be basically the same picture. Okay? If it is symmetric to the origin, it is what we call a odd function. Okay, because you'll have questions later on that will say, is it even or odd? Basically, if it's an even function, it's going to cross x-axis an even number of times. But an even function, it's possible that it don't even cross that x-axis. Like the one I drew here, this don't cross the x-axis, but it's definitely even. So an even function is the only one that might not cross the x-axis. So also any graphs that don't cross x-axis. Okay, because an odd, no matter what, one end is going to go down, and it's got to cross that thing sooner or later. But an even function is the only one that might be above and never actually cross it. Okay, these odd functions will definitely cross it an odd number of times. So they're going to cross the x-axis an odd number. Okay. Symmetric to the x-axis, hell, it ain't even a function, right? Because all these x's got two choices. So that's why we're only looking at mainly the y-axis symmetry and the origin. Okay. Now we'll have graphs that are symmetric to the x, but they're not functions. Okay, because those x's cannot have choices between y values. All right, so let me show you what kind of problems they're going to hit y'all with, and then we'll look at transformations. All right, so these are just going to say determine is symmetric to the x-axis, y-axis, or the origin. All right, so let me see what this was doing. What do you have on that? X, Y, or the origin? The Y, right? Because if I take my graph, fold it over to Y, it's going to land on itself. So definitely the Y-axis. I don't think this stuff's too bad, you know. Let me see. This is going to be a little tricky to draw, but I got it coming up and down. Then over here it comes down and up. All right, that's a great shot to draw that thing. It looks like a sine wave to me, or a cosine or something like that. But is it symmetric to the y-axis, x-axis, or the origin? So let's see. If we fold it along the y, this part right here is going to come down here, so it's not landing on itself. So it's not symmetric to the y. Same thing with the x, right? I fold it over, this part's going to come down here. It's not landing on itself. So the only thing is origin. If I took this and turned it upside down 180 degrees, this part would end up here and it would still make the same pattern, okay? So this one's definitely to the origin. Now there is one that's symmetric to everything. Let me show you. Well, there's that one right there. Check this out. This thing is definitely symmetric to the y, because if I fold it over, it's going to land right on itself. But it's also symmetric to the x, right? Because if I take it and fold it over, it's going to land on itself. But what about this? What if I took it and turned it upside down 180 degrees? It's still going to be a circle. So this one would be symmetric to the x, the y, and the origin, okay? All right, y'all, next we're going to see if these are even or odd. So determine if even or odd. All right, so this one has, it comes out and does that, and then it comes down, does that.
That's even, isn't it?
It's definitely even, because we said if it was symmetric to the y-axis, but also it touches it 2 times. So this is definitely a even function, okay? All right, so the last one, let me see what I get here. Well, that week off killed my reminder on it, I think. Okay, let's see. So this will be tricky. This one comes up, curves down, and then curves back up.
Odd.
It's odd, definitely. Symmetric to the origin, if I turned it, it would be the same picture, but it crosses that thing 3 times. Okay, so that's gonna probably be your best homework of the year. Them 5 problems right there, okay? All right, questions online?
No.
All right, so y'all ready? So let's knock out 7-2 transformations. We're going to take graphs and move them around. So there's some transformations we're going to look at, but y'all need to realize what the basic graphs look like, okay? So we're going to first look at what we call the basic graphs. So if we don't finish this, I might do a little Zoom on Friday just to catch this 7-2 up. But we got a few basic graphs. A graph that looks like a straight line going like this is the graph of y equals x. It's a straight line, okay? If x is 1, y is 1. If x is 2, y is 2, and so on, okay? Next would be our parabola. The graph of x squared. That would be y equals x squared. X cubed would be a graph coming up, sort of touching in there and going up. So the x cubed would be like the odds. Okay, we got another one here. Let's see. Any questions? Let me turn my speaker this way a little more. I'm getting me a headphone thing I can listen to and speak to.
When are they supposed to be getting your new thing set up? No telling.
They're supposed to be changing all these computers out and then doing whatever, who knows. What makes it V? So that would be your y equals. Absolute value of x. Remember that B, that absolute value always gives y'all that nice sharp B type graph thing. Oh. All right, let's see. This one goes. Oh, which one am I gonna do? So this one comes down, sort of makes it's sort of curvy. It's hard to draw that little curvy thing. It just sort of makes a little slight curve. This would be y equals the absolute, square root of x. So like 0, 0, if x is 1, square root is 1. If x is 4, square root would be 2, 9 would be 3, and so on, okay? All right, then the last one would be this graph comes down like this and curves. And then on this side, it comes in and curves down. This is y equals 1 over x, which is like the reciprocals of them. So if x is 1, y would be 1. X is 2, y would be 1/2. X is 3, it'd be 1/3. Okay? So whatever number you're putting in here is giving you the halves, the cubes, or the thirds. Okay? So we're going to take these graphs and we're going to move them up, down, left, right, flip them, all kinds of stuff. So here come our types of transformations. I can do a vertical shift, which is up or down. To do a vertical shift, I'm going to have y equals f of x. Whoops. So f of x will be like the x squared, the x cubed type stuff, plus or minus some number b. So I'm taking the function, figuring out what it is, and I'm adding a number to the end of it. So whatever answer I get out of that, I'm adding more numbers to it, which is going to increase those y's. Or if I'm subtracting them, it's going to pull them down. So if b is greater than 0, which means if it's positive, we're going to move up. If the b is less than 0, meaning it's negative, my graph is going to move down. Okay, so this means if it's positive, and this would mean if it was negative, okay? Second move I'll look at, horizontal shifts going left or right. So that would be like y equals f of x plus or minus a. So here's the difference on this, on these two. A vertical shift, you evaluate the function, then add or subtract your number. Horizontal shift, you add or subtract the number to the x first, then you evaluate the function. So it's just the order that you're hitting them with, okay? Now, this one's a little bit different than the vertical, because on this one, if that a is greater than 0, which means it's positive, we will move left. So if a is positive, it will move left. And then if your a is less than 0, it's going to move right. And that's when that a is negative. Because you're putting in different values basically for those x's when you're hitting them with them squares and stuff. So it's going to alter it off a little bit there. So the last thing we'll do in this section is we will reflect it across the x-axis. So reflect across the x-axis. Now, later in life, when we hit chapter 9 material, we'll learn how to reflect across the y-axis. But that deals with hitting those exponents. So to reflect across the y-axis, you're going to have y equals negative f of x. So once you evaluate that function, you're going to make all the values negative. So if they were positive, they're becoming negative and going to below the x-axis, okay? So like this one right here, if I make this negative, all these values would be flipped over into the negative side, okay? All right, so 3 moves, and then have these in your head. Now, I think I got the paper I'm going to send y'all. It's got those basic graphs on it, so that y'all don't have to try to memorize all those, okay? I'll try to remember to send that today. All right, also, here comes my examples. We're going to describe how the given function can be obtained from one of the basic graphs. Now, we'll say when y'all do these in math lab, you got to know which of those basic graphs it came from, the x squared, the x cubed, or the x, or whichever one, okay? So they're giving me y equals x plus 4 squared. So since you see this 2 sitting out here, this is definitely going to be the x squared graph, right? So in math lab, I would tell it that I'm going to start with graph y equals x squared, okay? But now I need to know, is that 4 being added to that x giving me a vertical shift, horizontal shift, or a reflection? Oh, I think I'm running a little bit long on my, I'm going a little bit past my edge there, but I'll fix that. So the one that has it hitting it inside the parentheses is the horizontal shift, right? Because remember, horizontal shift, that number is attacking that x, okay? So we're here on the vertical, you evaluate the function and then you add those numbers. So we're attacking the x, so we will shift the graph. Well, am I going to shift right or left? Adding that 4, that's a positive 4, right? Over here we said, hey, if A was positive, it was going to shift it left. So shift the graph left 4 units. And that's only move my hand on that one, right? So now at that point, you would have to graph it. Just remember that you got a square here when you graph this. You're going to have to use that quadratic, 3-point quadratic tool, okay? Oh, no. My bad. I think on these ones, okay, you don't have to graph them like that. On these ones, when you graph this, you'll select the tool you're using. So the graph, you want to select the quadratic tool, okay? Then click the origin. So once you select the tool, click the origin, which is at the 0, 0, it'll draw the parabola for you. But then it pops open another box. It'll pop open a box and it'll say like horizontal and vertical. And it'll have slide controls there. So since mine was going left 4 units, I'll look at the horizontal and move that left till I get to a -4. Once I move that to the -4, it's going to take my graph and shift it over for me, okay? And then if you have any reflections, I think there's also a box in there that says reflect over to X and reflect over to Y. You got them pulled up back there?
Yes.
Let me make sure I'm telling you all the truth. Yeah, so like on yours, you had +7. So take that horizontal and move it to a -7 because it's actually going to move me left. So you would come over here. What's that at?
-7.
Let's see how it moved it for us. Now, if you have any reflections, you just click the mud boxes. So save that, and it already goes. So I love that part because you're just picking the tool you need and then sliding in controls and it'll move the graph for you, okay? And so, y'all, what would happen on this one after you translated it? Remember, the basic graph started here at the origin. So since we left 4, over here at -4 would be where the origin would now be, okay? They're not bad, it's just keeping up with all these moves. All right, so I'm just gonna put the equation. This one is h of x equals negative 2x plus 4. Oh, they were supposed to take this one out of here. See if your number 4 looks like my number 4.
Number 4.
Yeah. Yeah. So you didn't end up, it looks like mine, negative 2x plus 4. All right, so I'm gonna redo this one. We took this one out because that 2 being in front of that x stretches it and shrinks it, and we don't cover that really. So, same problems, y'all. All right, so let's do this one. G of x equals negative x plus 4 to the third. I've got a few things going on this one. First, I'm going to start with the basic graph. So start with y equals x to the cube, right? You know, a lot of these, the squares and the cubes are not bad because you see them exponents. Absolute value is not bad because it's going to be absolute value bars and stuff, okay? I got 2 things happening here. I got this negative sitting in the front, and I've got that 4 sitting inside that parentheses. So let me start with that 4. Since that 4 is inside the parentheses, I'm attacking that x, which means I'm on the left or right. So we're going to shift. And to me, these are always opposite on the horizontal. I would think adding 4, you're going right, but remember, you're really going left. So we're going to shift left 4 units. And then I got that negative in the front. That negative is going to reflect me over the x-axis. And that's only 2 things happening to that one. Now, when you graph this one, you're going to grab the cubic tool. It'll be a little squiggly line. So the graph, choose, should be a little squiggly tool in there. And then click it into the origin. So then click the origin. Once you choose that tool, click the origin, it's going to make the graph in the middle. And then you got to hit the slide controls. On the slide controls, we're looking for what? A horizontal. Move that to -4. Also, there will be a little box down here that you click that will reflect it over the x-axis. Okay? So reflect over x-axis. I've got a video that does a lot of this on it, so I'll send that later too. Other than this little recording we're doing in here, that actually does the graphing in the MATLAB. Okay. All right, so let's do some moves in one of these. Let's see. Oh, this one's pretty cool. F of x equals a square root x plus 11. Now, we'll say this one, when you look at it, it had multiple choice answers. So look around 7 or 8. It'd be toward the end more. They might think they're out there, huh? Other than mine just being added, yours being subtracted. So that's your square root graph. So start with y equals the square root of x. So what we need to figure out, that 11, anytime stuff is under a radical, we treat them like they're in parentheses. It's like all this stuff is in here inside of parentheses, okay? Which means it's another horizontal move. For this to be vertical, that plus 11 would be outside that radical, okay? So, since I'm attacking that x with that 11 and it's positive, I'm actually going to move left 11 units. I guess that was it on that, right? So they had 4 pictures on that one. They'll have a picture where they moved it way right, one where they moved it left, one where they moved it up, and one where they moved it down. Remember, y'all want the one where they moved it sort of to the left. So this one, when you're done, because remember, since that's 11, this would be really starting at the 11. Because remember, 11 minus, we'd be over here at negative 11, my bad. Because negative 11 plus 11 would give you 0, absolute value of 0 is 0. But anything more negative makes it imaginary. So if I got past that negative 11, it'd be imaginary. So over here at a negative 11, your graph is sort of just want to make a little, but notice, it's left of the origin, okay? I think I seen one in yours that looked like this. G of x equals cube root of x plus 4. I think that was actually your number 7, something like that, wasn't it? So I'm starting with the cube root on this one, right? So start with y equals the cube root of x. And really the only move is that plus 4. But guess what? That plus 4 is not under the radical, so it's not really attacking that x. So on this one, you would evaluate the function first, then add the 4. So that's going to be the vertical moves, okay? So if it's inside parentheses with the x, left and right, outside, up or down. So let's start with the graph. Y equals the cube root of our x. Since the 4 is positive, will I go up or down? Up. There you go. So we'll shift up over that 4 units. Special on this one, let's see, my cube root. This one had pictures too. So this one had 3 pictures, but we want the one where it went up, so it sort of looked like it shifted up a little bit on them, okay? One looks like it'll go right to the origin, and then one is going to be a little bit lower. Let me see if yours didn't like mine. Yeah, but yours was -3, so you would go with, see yours. All right, so I got one more, so we ought to be able to get this one in time. G of x equals negative x minus 7 squared plus 2. So you know I had to bring one with all the moves on it. So that should be like your last one on there. So it's got all the moves. So I guess I'll go left and right. I know what graph I'm starting with. I'll start with what? Y equals? X squared, right? So let's see, I got a negative in the very front, I got a -7 in with the X, and then I got a +2 sitting at the end. So I guess I'll just go in order. That negative will reflect me across the X-axis. Because guess what? We don't even do the Y-axis yet, so if y'all ever say the Y-axis, I'm gonna get you. So reflect across the X. Right 7, because that's a -7. So that would shift right 7 units. So how about that 2? I got me a +2 sitting at the end.
Shift up 2.
Up 2. That's it. Because remember, anything at the end is taking all those values you're getting, and it's just adding 2 to all those Y value answers you're getting. So shift up 2 units. So when graphing this one, it actually made you graph this one. So to graph, I'm going to choose the parabola tool again. So anytime you got them X squared, you got to go with that quadratic tool, they call it on there. Then click the origin. And I don't think you actually specifically have to click it in the origin. I think you just mainly got to click it on the graph and it'll stick it in the origin for you. Then this one has 3 moves. You got to do the horizontal, shift in, the vertical, and then remember down here, you got to click the reflect over the X. Okay, so horizontal, since that's a -7, I would move that right to a +7 because I'm moving it right 7 units. And then the vertical, I would shift right, then I hit my +2. Okay. And then remember, check that little box down there for reflecting it, and it'll do everything for you. Save it and hit in. So you're sure to have all 3 of them moves on too, I bet.
What for?
Oh, yeah, you done got them.
Number 8, it only had those.
Oh, we didn't even have to grab it. So you didn't have to grab that, no well. So let's fix one of yours. You had a red.
Yeah. Enter the second part of it.
Oh, right. Oh, okay. So you get Simmer if you want to be knock that out, then let you knock it out and get it. Put it on that. All right, so I see no reason for a class Friday. Next week, so I want to do all that quadratic stuff next week. In the next few sections, it'll be dealing with quadratics. So are y'all decent at factoring? No, so we're going to work on the factoring. So I will say, when it deals with quadratic type equations, you either want to get good at factoring, but the main thing you can get good at that'll pretty much solve any quadratic is the quadratic formula. You remember that? So this is what we're looking at Monday. Does it start to look familiar? Yes. Start to get it all over 2A.
I think the only thing that looks familiar is the 2A.
Yeah, someone was telling me they were singing a song that rhymed with "Pop Goes the Weasel" or something to memorize that in school. I never really did that back in the 80s. So, but guess what? I gave y'all a program that does the quad formula. So if you're weak at doing them radicals and solving those, calculator's nice. So all of y'all got my programs, didn't you? If I've ever hooked up to your calculator, you got them. All right, so let's see. I'm gonna quit sharing the screen for y'all. Anyone online got questions?
No.
All right, so we're not gonna Zoom Friday, because I still got people that need to take test one. Test one is due Sunday night. Now, every assignment will let you work past due dates except for my test. Okay? So if you don't get that test done by Sunday, it'll put a 0 in there, and that'll stay until the final exam. If that's your lowest score, I'll replace that with the final. So y'all will get one low score replaced with the final if you need. People usually do good on the final, so don't freak out about it. It's multiple choice, 25 questions. And on the final, we just touch everything. We don't get deep into it. We just do like basic knowledge on that stuff, okay? But there will be those 3 system equations and some of that fun stuff on there. So it's got tough sections. But overall, people usually do really good on it. So I'm usually having to switch a lot of no tests out, you know, so it's not bad. Trick to this class is just getting through it. Chances are, if you just get through it, you're going to pass. Okay. Because hell, I'll do bonus work if I got to. Did y'all do my bonus for test one? So I sent y'all an email. Oh, it would have been not last week, but the week before, that said test one bonus. It's just a Word document or a PDF document, whichever one you want. And it got 3 questions on it. But I will add up to 5 points on your test. That's half a letter grade. So if you
Hey,
made
Mr.
100,
Raffo.
so if you made 100, I can turn that into a 105. 95 turns to 100, and so on. Now, if you've already done my test, I haven't added in the bonus yet. Okay?
Okay.
I'm just sort of waiting on people to get through it. But some of y'all have already done it. I just haven't added y'all's bonus in.
I've done my bonus. Do I need to bring it to class or just email it to you?
Y'all can well, I gave y'all several options. I think you could email it back, bring it to class, or hell, I gave y'all my text number. Y'all can take a picture of it and send it to me that way.
Okay.
Okay. So either way. And so y'all good luck on that test, and I will see y'all Monday.
Yeah.
And we'll start knocking out 7.4.
Okay.
All
All right.
Thank you.
All right, and I'll get this sent out later for y'all, okay?
All right. Thank you.
All right, y'all have a good week.
You too.